It's now time to embark on our next session, a spotlight presentation on green hydrogen, a sustainable substitute for coal by Mr. Kaushal K. Vaishnav. Mr. Vaishnav has multifaceted expertise in the energy sector across business development, project management, and regulatory. He is currently working across the energy and infrastructure segments. He has been involved in EPC as well as consulting projects of national and international repute, working largely across state and central government entities. He has also worked with Fortune 500 companies on multiple projects based in Asia, Africa, and the Middle East. Over to Mr. Kaushal to share his screen and make the presentation. And Mr. Chandrashekhar would continue to be with us to lead this session. Mr. Kaushal, if I would request you to please unmute and get your video on.
So thank you so much, Shreya, for the brief introduction, and I really thank CE for providing the
Could you be
platform.
a little louder? Because, okay, yes, I can hear you now. Yeah, that's fine.
Yeah, hope now it is audible.
Yes, yes.
Yeah, so thank you so much, Shreya and the CA team. Also, very good afternoon to each and every panel member and our attendees. So I think we have half an hour of time for the session, and I will quickly jump to my presentation. So
Yes.
just
Are you
please let
able
me
to
know.
get your video on, Mr.
Shreya, actually, I am traveling and I think I'm
Okay,
presenting it from a moving vehicle. So I think keeping the connectivity in check, if I open the video, I think it might hamper the voice
I
also.
understand. Yes,
Yeah,
I've given you the share screen access, so you can have your presentation up on the screen.
sure. Just please let me know once my screen presentation is visible to you.
Sure. Yes, we can see your presentation. You could go on the slideshow mode.
Yeah. Yeah.
Yes, you could continue.
Sure. Thank you. So welcome all. My topic today is green hydrogen, a sustainable substitute for coal. So I will give you a brief details in the agenda of this presentation. So it covers basically a introduction, then coal versus green hydrogen, a generic comparison, how and I mean why we should move towards green hydrogen. Then green hydrogen related production and application topic. Next one will be the electrolyzer and its technologies. Then I will cover development plans and policies for green hydrogen in India. Next, I will cover challenges and solutions for adoption of green hydrogen. And then, which is the main topic, is the green hydrogen as a coal substitute and what are the case studies relevant to it. And then the forum will be open for the Q&A. So I will move to the next slide. So as we all are aware that now our world is facing the environmental challenges and we are in the process of transition to move from fossil fuels towards the sustainable fuels, right? So, and we want to combat the climate change and also want to improve the air quality. So there green hydrogen emerges as a viable alternate and which actually offers a sustainable future, and also it has immense potential to become a green fuel. So basically green hydrogen refers to the hydrogen gas produced through the process of electrolysis, which uses the renewable energy either solar or wind as a power source. The image basically shows you a brief process how exactly it is done. So we have a renewable energy source, and then it is fed, the power is fed into the electrolyzer, and the water is basically electrolyzed there, and the hydrogen is collected, and it is then again stored and distributed for the various commercial and industrial applications. And that is how the whole this whole value chain helps us to achieve the net zero. Now, coal versus green hydrogen. So what are the environmental concerns with the coal? So obviously we all are aware that greenhouse gas emissions is a larger problem with the coal plants. So basically these greenhouse gases and emissions, they actually impact or basically are the primary driver for the climate change, and which results in the global warming. Next is air pollution. So burning coal basically releases various pollutants like SOx, NOx, mercury, and particulate matter. Water pollution. So coal mining basically contaminates various water sources through the release of heavy metals, acid mine drainage, and coal ash disposal. Fourth one is the land degradation biodiversity loss. So wherever are the coal mines, it generally often involves a lot of removal of the vegetation, plantations, topsoil, and then the loss of biodiversity happens through all these processes. So with all those key concerns in place, next I will cover how green hydrogen emerges as an important fuel or important solution there. So since green hydrogen basically does not emit any CO2, SOx or NOx or other greenhouse gases, so basically it is helping us in the carbon emission reduction. Second is air quality improvement. As I mentioned that it is not having any particulate matter which is getting released via using this fuel. So there is no SOx, NOx which we are releasing through the plant. So the air quality is getting improved. Third one is the integration of the renewable energy sources. So if we are having excess renewable energy, which could be utilized basically to produce hydrogen, and then it could be stored, and later again it could be converted back into the electricity. So it basically gives you energy stability or the power stability as we call it. Fourth is a diverse application. So basically, hydrogen could be utilized into multiple sectors, and it has various applications. Like we could use it as a clean fuel for transportation, into industrial processes, and again, as I covered just now, that the power generation through the fuel cells. So this slide basically covers a brief introduction to how green hydrogen is produced and what are the key applications. So as you can see from the image as well, very first we have to have a renewable energy generation or a renewable energy source. The power generated through those source is basically fed to the electrolyzer, where electrolysis happens, and then after electrolysis, the hydrogen generated is collected at the source. Once, since the hydrogen collected might have certain impurities, it is either during the process or through the water which we have used for the hydrogen generation. Impurities might also be collected at the source. So basically, to remove those impurities, we put it in the process of purification. And once it happens, it is basically sent for the compression, and after compression as at the required temperature and pressure, we basically put it into storage, and from that point it could be distributed to various sources where it is utilized. So that is how the value chain of hydrogen production works. Now, talking about the key applications, so again it is the clean fuel for transportation, power generation through hydrogen combustion. That is the key topic for our presentation also. I will cover it in detail in the next slides. Then industrial processes, energy storage, heating and district energy, like we could utilize the green hydrogen as a fuel to basically generate energy or power, which could be utilized for the heating applications. It could be utilized for individual house heatings, or the whole overall colonies, commercial complexes, or malls. So those are the heating energy applications of hydrogen, to basically generating heat through power. And then energy export and industrial trade. So green hydrogen could be traded as a product, could be there could be international market for trade for green hydrogen due to all those applications. This next slide basically gives you a visual effect of what I just elaborated. So you can see there are three key components of the image. One is the feedstock, second one is the hydrogen production storage, and third one is the commercial and industrial applications. So as I mentioned, we have to have a source of green energy like renewables or hydroelectric. The power which is green in nature is fed to the electrolyzer, where the electrolysis process takes place, and then again similarly it is taken for collection, purification, and everything, and then it is put into storage, and from then onwards it is sent to various industrial and commercial application for various commercial and industrial applications via carriers, and that is how this whole cycle works. Now, covering what are the key electrolyzer and technologies. So we have total key 5 technologies and type of electrolyzers here. Very prominent of them is PEM and alkaline. So I will cover them in a very briefly manner. So PEM is proton exchange membrane electrolyzer. Basically, they use a solid polymer electrolyte membrane to conduct protons and while preventing the migration of electrons. And these basically operate at a generally low temperature, which is around 50 to 80 degrees centigrade. The alkaline electrolyzer basically uses alkaline solution, and it is typically potassium hydroxide as the electrolyte, and these operate at slightly high temperature, which is 80 to 90 degree. Third one is SOEC, solid oxide electrolyzer cell. They are high temperature operated electrolyzers. The temperature range typically goes above 800 degrees centigrades, and they basically use a solid ceramic electrolyte. Fourth one is solid polymer electrolyte, SPE as we call it. And these are again very similar to the PEM electrolyzer kind, but the difference is that they use a different type of solid polymer electrolyte membrane. And they operate at a temperature of around 80 to 120 degrees centigrade. The last one is photochemical electrolyzer. So PEC, PEC electrolyzer, it utilizes basically the solar energy directly for the electrolysis process. And they typically consist of a semiconductor material that absorbs the sunlight and generates electron hole pairs, which facilitates the water splitting during the process. So, quickly covering the green hydrogen development plans and policies in India. So the very prominent ones are the like Green Hydrogen Energy Mission (NHEM). So it was established or launched in 2021, which basically it's comprehensive. The focus is basically to provide a comprehensive roadmap in the hydrogen energy sector in India. It basically promotes the development and deployment of hydrogen, R&D activities, new technologies, and fostering domestic manufacturing capabilities, building necessary infrastructure, and creating a enabling system ecosystem for hydrogen adoption. Second is hydrogen cell. So hydrogen cell is an integrated part of MNRE, Ministry of New and Renewable Energy. Since this is a dedicated ministry for the renewable energy sources, and renewable energy sources being a key part of hydrogen generation process, the MNRE extends its support on the hydrogen side as well. And basically this division focuses on policy formulation, R&D activities, international collaborations with any technological players or the developers or generators, and then it also demonstrate the technology of the projects which could accelerate the hydrogen adoption in the India. Third one is the green hydrogen purchase obligation. So it is very similar to the renewable purchase obligations RPOs, which have been floated by the ministry in the renewable energy. It could basically the idea to have GHPO is that it could basically help you to basically it will mandate certain industries and consumers to procure specific percentage or amount of green hydrogen for their operations, which would encourage the demand of green hydrogen and then help in growing the market. Fourth is hydrogen roadmap. So the government has initiated a deployment of national hydrogen roadmap, as I talked about the earlier part. So basically, its idea is to identify key areas for the hydrogen deployment, such as it includes sectors like transportation, power generation, in industry, and the storage. So roadmap basically it outlines how exactly the necessary policies should be formed, what could be their measures, what are the infrastructure requirements, what could be the R&D requirements, what could be the technology requirements, and how we could scale up the hydrogen production in India. Fifth is the incentives and subsidies. So government shall be adopting or considering to provide incentives and subsidies to promote the green hydrogen related projects. It is, the hydrogen still is in very beginning phase of its beginning phase in India. So these things are still, we can say, the work in progress. But again, these are all the considerations which government has to look for and then provide the necessary inputs. And just to talk about various schemes or programs under MNRE are there, and they could help you to basically grow or understand more the hydrogen market and support you for the green hydrogen related activities. The sixth one is the international collaborations. So Government is basically actively eyeing for international collaboration, signing MOUs or engaging with the international parties which have prior experience of doing such projects, and would be happy to get technology transfer in the hydrogen sector. So these collaboration agreements or MOUs has been signed with various countries like Australia, Canada, UAE, and they are still exploring few areas where hydrogen production, storage, and utilization could be a part of it, and it could enhance the visibility in the Indian market as well. Now, I will cover what are the key challenges and solutions in the adoption of green hydrogen. So the very first problem which we all are aware is that the cost of green hydrogen production is very high. And why actually it is so? Because the cost of renewable energy sources, I mean the power we get through renewable energy sources and the electrolysis technologies, their cost is high. And these put combined basically causes higher cost than the conventional sources. So that becomes a hiccup when you want to adopt the green hydrogen as a fuel. So what could be the solution? The solution is that we need to have improved and continuous R&D with the technological advancements, which could drive down the cost of electrolysis technologies, and then also scaling up the productions like mass production of hydrogen with which could be achieving the economies of scale, and government incentives could also play a vital role and could help us in reducing the overall cost. Second is infrastructure development. So establishing a dedicated infrastructure for green hydrogen production, storage, transportation, sorry, and distribution, it is a major challenge because since the nature of green hydrogen is very flammable, so we have to take all the safety measures in place. So that's how we have to have an infrastructure for green hydrogen which is complementing its requirement. So talking about the solution, so what could be the solution? That government and private players could come up as a PPP at a PPP model, public-private partnership, so that it could be helping to mitigate the challenges related to the uh, 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 electrolyzer installations, hydrogen storage facilities, or hydrogen refueling stations for the transportation activities. So if those two sectors like government and private come into picture together, the PPP could be the modus operandi basically to take the next steps and grow the sector. Now, third one is renewable energy integration. So the challenge is that the nature of renewable energy is intermittent because the matching of the availability of renewable energy with the demand of green hydrogen production is a complex task, because you have to make sure that renewable energy is available at the time you are producing the hydrogen. So how to mitigate that? The solution could be that advancement in energy storage technologies like fuel cells or batteries, where hydrogen could be used as a fuel and it could be stored as in terms of power or energy, and it could basically the energy stored could be helpful in bridging that gap, so that whenever we are having a requirement to produce a green hydrogen, the stored energy could be utilized there so that the production is continuous. Fourth is policy and regulatory framework. So the challenge is that we, in the absence of supportive policies, clear regulatory framework guidelines, it actually impacts the adoption of green hydrogen as a fuel. And also, whenever there is a lack or there is ambiguity, and there are no incentives, the market access becomes limited, and investments are in a way discouraged, because unless the regulatory framework is not clear, there would be no growth in the market. So what could be the solution? So government basically need to come up with the clear, stable, and supportive policy frameworks and regulations, such as feed-in tariffs, tax incentives, grants and subsidies, and increase R&D, so that these barriers could be addressed for the market entry, and which enhances the promotion of green hydrogen. Fifth one is the technological and advancements and research. So challenge is that continuous research and development requires a lot of efficiency and performance improvement on the electrolyzer side, and as well as it has to address challenges related to the markets, materials, catalyst, and the system integration. So how we can do that? What could be the solution? So we have to increase the funding for the research and development organizations to conduct the R&D in the right direction with the right resources. And with that, I think it could be a stepping stone. If the R&D could take us forward and bring us the cost-effective solutions, that could help us achieve this target and result in the cost effectiveness. So sixth one is the public awareness and acceptance. So until unless the public awareness is not there, the adoption of green hydrogen will not go till the extent it is required to be. So public has to adapt the practices and the green hydrogen as a fuel. So that becomes a challenge. And how we can do that? We have to implement public awareness by campaigns, engaging with communities, and highlighting the environmental and social benefits the green hydrogen provides. So with that, the acceptance could be increased, and we could also demonstrate through successful pilot projects to the public that this is how the work should be done, and that could become an example, and that's how the public perception could be changed, and they could be motivated to accept the green hydrogen as a fuel. Now, the main topic is that green hydrogen as a coal substitute. So, green hydrogen could be utilized as a substitute to coal in two ways. So, one I am covering here. The first is that green hydrogen as a fuel in boiler. So, there has been multiple research, and still it is in progress. So, green hydrogen could be utilized as a direct fuel to fuel in boiler, which actually offers you sustainable and low carbon alternative compared to the conventional fuels. So by replacing the natural gas, coal with green hydrogen, emissions and greenhouse gases and the other pollutants, these could be minimized. So what are the key pointers related to green hydrogen in the boiler firing? So first is the combustion process. Green hydrogen can be burned in a boiler using a combustion process similar to that of natural gas and other fuels. So whenever the green hydrogen is injected into the boiler for combustion in the chamber, it is mixed with the air before it is ignited. Second is the emission reduction. Since as I covered, it is not having any SOx, NOx or greenhouse gases, or no CO2, it actually helps to reduce the emissions. Third is the infrastructure adaptation. So basically, when we are feeding green hydrogen in the boiler, definitely there has to be certain adjustment to be made in the combustion system or the burners, and certain replacement to accommodate the specific combustion characteristics of the hydrogen. And accordingly, since I mentioned it is a very highly flammable gas, you have to make sure the safety measures are in place, and appropriate equipment design should also be the consideration according to the unique properties of hydrogen, and then only you can take this exercise. Next one is the energy density. That plays a very key role, because as we are aware that hydrogen is having lower energy density compared to the conventional fuel. So that means we need larger amount of hydrogen to generate same amount of heat when it is compared with the natural gas or coal. Cost considerations. Since right now the cost of green hydrogen production is quite high, and that is the reason I think until unless it is not coming in the equivalence of the conventional fuels, or until it is not getting below to that, it will not be a mass scaled fuel for or it will not be a mass uh, opted by masses as a fuel, as a coal substitute. So to make it happen, we have to work on reducing the cost of green hydrogen production. Other one is the R&D. So basically various R&D efforts need to be put in optimizing the combustion process, improving the burner technology, addressing the challenges associated with the hydrogen firing in boilers. And basically those all like apart from that, there are a few other points like flame stability need to be there, emission control, efficiency enhancement, so that we could maximize the green hydrogen in the benefit of green hydrogen in the boiler applications. The second one is a green hydrogen from, the power generation from green hydrogen using fuel cells. So this is a very innovative and sustainable approach that basically helps you very clean and efficient electricity, and also since it could be part of the energy storage. So basically, it helps you to provide energy in the remote areas, or in the areas where you could seek power stability. So how exactly it works, I would give you some insights on the basics. So fuel cell basics. So fuel cells are basically electrochemical devices that convert the chemical energy stored in it as a hydrogen fuel into electricity. And they operate through electrochemical reaction between hydrogen and oxygen, typically from air. And then again, the same anode cathode reaction takes place, and through electrolyte membrane. And basically, water is the byproduct. Hydrogen input. Green hydrogen basically produced through electrolysis and powered by renewable sources. It serves as a input fuel for the fuel cells. Then hydrogen is fed into the anode side of the fuel, where it is split into protons and electrons. And electrons basically flow through the external circuit and creating an electric current. And proton moves through the electrolyte membrane to the cathode side. Oxygen input and water formation. Oxygen from the air is basically supplied to the cathode side of the fuel cell, and then at cathode, the oxygen molecule combine with the electrons and protons that have traveled through the external circuit. So this reaction results in the formation of water as a byproduct, and making fuel cell as a clean and environmental friendly solution. Power output. The flow of electron through the external circuit generates an electric current that can be utilized to power electrical drives, equipments, and grid connected systems. So that is again on the emphasizing basically that the fuel cells of green hydrogen could be utilized as a stable source of electricity. It is efficient in application, as I've covered, because the efficiency typically ranges from 40 to 60%, which is depending on the type of fuel cell in place. So basically, it is said that they are versatile and could be utilized for various applications into industry like power generation, transportation, portable power, and backup power systems. These are again the advantage of the same, that this could be utilized as a stable source of energy. It is clean and a low emission technology, which produces water only as a byproduct, no emissions, no SOx, NOx, no greenhouse gases. So that way it is sustainable and environment friendly. And these are the key applications. Now, quickly talking about the key case studies. So I have covered listed 3 projects. There are multiple such projects. If you Google, if you check the hydrogen trends, there are multiple such projects in place, mostly in the European or Western region, Western countries. So the first one I have covered is the Ørsted's Avedor Power Station in Denmark. So basically this project the project involves basically converting one of the facility's coal-fired unit to a hydrogen firing unit, which utilizes the green hydrogen produced from the renewable sources. So basically they are directly firing green hydrogen in the boiler and generating the electricity. Second one is the Eneco's green hydrogen power plant in Netherlands. So Eneco is basically using green hydrogen fuel cells to basically store the electricity, and these are the hydrogen fuel cells, and which basically provides them flexible and clean power to support the grid during the high demand periods, and also intermittent renewable energy supply. Third one is the High Stock project. It is a US based company. The High Stock project is basically it involves the construction of large scale hydrogen generation facility. So the facility uses surplus renewable energy to produce the green hydrogen. The primary source of green hydrogen production, or the primary source of power for the green hydrogen production, is wind power, and they are utilizing this hydrogen after storing and various processes. Basically, they are utilizing it for the power generation, transportation, industrial processes, and that's how it is contributing to achieve decarbonization in multiple sectors. So those were the key case studies on the 2 solutions which we have as a sustainable fuel for the hydrogen. Now, since it is almost time, I would open the forum for the Q&A. And just to give an idea on EPA, basically, so recently this has been introduced, and basically it is a forum of professionals where people are connected with each other through WhatsApp groups or through a professional community. It is a group for the people, by the people, operated by them. It is a free of cost group. It is only focusing on the key insights, developments, technologies, key outputs, business opportunities in the market, so that professionals working in those segments are updated. So that's a generic effort to basically enhance the learning and knowledge of our professionals and keep them connected. Now, I would request the esteemed panel members to open the forum for the Q&A. Thank you.
Mr. Kaushal, can I request you to stop your screen sharing, please?
Sure. Thank you.
And if possible, since you're not sharing the presentation now and only for the Q&A, if you could have your video on, it would be great. Yes, Mr. Chandrashekhar, over to you.
Yeah, thank you, Mr. Vaishnav. Of course, this is an emerging market. I have only a few questions to you. One is, you must be aware the extent of stressed assets in India, including several imported coal-based thermal stations, and of course the natural gas units of the order of almost 25,000 megawatt. A majority of them, bleeding and because of non-availability of gas. As I know correctly, GE has gone ahead with converting some of these gas turbines to be fired on hydrogen fuel. So considering that, how do you perceive the market in India, both with respect to gas turbines and the stressed thermal power assets?
So, sir, definitely, you have mentioned it right that there are multiple such strats.
Can you be a little louder, please? We can't hear you properly.
Hope now I'm audible.
Yeah. Yes.
Yeah. So yeah, indeed, you mentioned the right state of the power plants in our country. Definitely, it is a concern as well, because I see the PLFs are down and they are not being operational at their full capacities. But again, the derive of achieving sustainability, derive of reducing the pollutants or getting the clean air is a separate topic in my understanding, rather than talking about how we could integrate those efficiencies. I think it is a very complex matter which could be again requiring a lot of support from the government side on the policy matters, or to how actually we could give certain subsidies, because obviously there are fixed costs which are associated with the plant, and plants are running in losses at that point of time. But when it comes to the hydrogen side of it, the fuel, as a fuel, we are still in the very early stages. It is very early to say how it could be complementing those stressed assets, because until uh, uh, the ROI, the cost which basically we are going to put in place if we implement the green hydrogen as a fuel, that is not there, and those specific strategies are not there, those policy frameworks are not there, it will not make a sense to just go and implement, and also vice versa. So I think basically we have to give it some more time, so that if, and apart from that, let's not just think that for the stressed assets, green hydrogen side could be only the solution. There could be multiple other solutions. By that way, their performance or the utilization of those plants could be enhanced, or they could be better utilized to produce power. So there are other topics also which also integrates in that thought process.
Any detailed feasibility report being prepared to convert one of these gas-based power projects into a running plant, because they are all practically not operating since many years?
Sir, to my best knowledge, I have not come across any such plant in India. I could give you one more example from USA, where I have been with a company which is doing the EPC of that project. It's a Utah-based project in USA, and practically it is the second largest project. Mitsubishi is the client, and my company was doing EPC for that. So basically, they were initially achieving 25 to 30% of green hydrogen feeding in the boiler, and gradually they would like to increase it till the 60 to 70% in the progressing years. So that's how it is. Even in the US, there is not such a plant where they are using 100% as a hydrogen fuel source. I mean, 100% hydrogen fed into boiler. I have not come across. If I'm missing, my apologies, but this is what my understanding is.
In,
So
in
I think,
your in your opinion, sir, what would be the cost comparison between a natural gas and the hydrogen fuel?
sir, again, it
So
is
in
very
terms of course, the per kilocalorie, I'm saying, not as a general costing.
sir, it's hard to define because it very much changes with the country's resource availability and the dynamics. So there is no such a study where I have come across, being on the consulting side as well.
Okay.
And I have not come across any study which could define or kind of state you or give you any figures.
Okay. Well, I suggest, of course, the last slide you gave your contact details and address. If you can kindly share with share it again, probably, or I will ask Shreya to share it with me. Probably we can approach you to find out a possible market, at least on a
Sure, sure.
on a
Sure.
We will pass it on to
on
you.
a pilot basis, how to put it in streamline.
Definitely, sir. I will do that.
Okay,
I will
thank
share
you.
that with the share.
Thank you.
Thank you.
I was also seeing a point in the Q&A box from DB Power Manoj Kumar Panda, which mentioned what are the capacities of case study projects of power plant from hydrogen?
Okay. So these are small scale pilot projects mostly. So I think due to NDA part of it, I will not be showing more details on the plants, because again, every company is trying to achieve the sustainability and doing the pilot projects as per their policies and procedures. So that's why I have kept the plant details very generic, because I think as a mature professional, we all are aware that these are the emerging technologies and areas, and multiple people have kept multiple caps in terms of the information sharing. So that's why I didn't wanted to go too much in the details of the project. However, the capacity could be shared, but again, since I've given the slide the company name and logo, I think it could be very well googled, and it could be taken care of. So just as a, because there are few equations like we could be working with the competitor and all, I would not like to put forward those details of the company.
Sure, sure, sure. Okay, with that, thank you so much, Mr. Vaishnav. I know you have been traveling, but you've kept your commitment with us and continued to be with us on this session. So thank you so much. Mr. Tyagi, I
Yeah,
see you
yeah,
have
I
put
have
your
one question only, very short question.
We'll take just
Sure,
one
sure, sir.
question, sir, because I need to move on to the next session.
Okay, okay. Only if there any feasibility study has been conducted for the use of the hydrogen in brick kiln industry, which is very, very bad in the pollution.
Sir, to my knowledge, I have never explored that topic. So it will be a false information to say yes or no. Frankly, I can check and I can come back to you on that line. But again, on that industry, I have never actually explored or even searched the use of green hydrogen in that line. So if required, I can basically put some time and check it.
Oh, okay. Thank you. Thank you.
Thank you, sir.
Thank you.
So
Thank you so
thank you so much, Riyal, and thank you, CE, for the great opportunity to share my insights here. Hope this would have been a beneficial presentation to all the attendees. And thank you so much for taking out the time and listening to me. Have a nice day.
Thank you. Thank you so much, Mr. Vaishnav. And thank you, Mr. Chandrashekhar, for always extending that time and support to us. And we will look forward to you joining us in the awards ceremony in the evening as well. And thank you so much. I will now move on.
Just give me a message when you're ready with the award ceremony so that I can be here. Because otherwise it is 3:15 as per your calendar.
Yes, yes, yes.
Yeah.
But my team will keep you updated on
Okay,
that.
thank
And
Yes.
Shreya, also,
Thank
I would
you.
like to share one thing. So,
Yes.
I mean, my apologies that I could not keep my videos on and everything, so due to my travel schedule and everything, keeping the connection requirements. So I will be sharing this presentation with the Shreya, and also you can find me by my name on LinkedIn, and that's how you could connect with me. And also my number will be there with Shreya. You could please
Yes,
ask
yes.
for it, and I'm happy to connect with you at offline mode also, and we can discuss the further topics. So thank you so
Sure,
much.
sure. Okay, thank you so much, Mr. Vaishnav. And all